Okay, we'll just go and have a look at the Corey-Chaykovsky reaction. Oops. Corey-Chaykovsky reaction. You have to excuse my poor writing. So the Corey-Chaykovsky reaction is a really good reaction for making epoxides. So basically we take a sulfonium halide. So if I have sulfur and I have a CH3, CH3, that's going to be a sulfonium ion because sulfur's donated electrons into that methyl group there. And this can be made from dimethyl sulfide and iodomethane, in which case you get the trimethyl sulfonium iodide. You treat this with a base, for example sodium hydride, and it'll deprotonate one of those protons to give you an ylide. Now we've seen the ylide before, we've even seen the sulfonium ylide if you remember the Swern oxidation. If not, I encourage you to have a look at the Swern oxidation reaction. So we find that sulfonium ylides are relatively stable. I wouldn't say that that's stable, but stable enough to exist, to react with. So that'd be CH2 and a minus charge there on the carbon. And then you've got sodium iodide floating around in solution. Now, sometimes that's written as a double bond, but if you look at the orbitals, there's no orbital for that to actually go into. So it can only go into like a 3p orbital or something like that. So it's got the wrong energy and the wrong overlap really. So it's best to write it as the ylide structure. I always write them as the ylide structures, but you can sometimes see them as double bonds. Okay, so we've got our ylide. This is our reactive intermediate in the Corey-Chaykovsky reaction. I'll just move this down a little bit. And we need something to react it with. So usually what you take is an aldehyde. So if we take benzaldehyde or something like that as an example, and we react this, I react that with the carbonyl, we should get or minus the CH2. I'll tell you what, I'll write that CH2, and I wouldn't normally do that. CH2, and I might as well write them like that as well. CH3 plus. Okay, and of course we've got the phenyl group there, and we have a proton there as well from the benzaldehyde. So the next step is to form the epoxide, and that's done quite easily by having a fine leaving group there in the form of the dimethyl sulfonium species. So the oxygen can kick out the dimethyl sulfonium ion as an excellent leaving group to form the epoxide. So I'll just draw that. So there's the final product plus dimethyl sulfide, which obviously has the rotten cabbage smell. And these protons here are from the CH2 group there. So you can imagine if that was if you DMS attacking a different alkyl halide, then you could actually incorporate some alkyl group here and another proton, or maybe it's a different species altogether. And then you've got to think about the chirality of these centers as well. So that is the Corey-Chaykovsky reaction from trimethylsulfonium iodide reacting with an aldehyde to give an epoxide.